Okay, welcome back to part 3 of this lab. Um, so part 6 is just like a kind of comment where it tells you how lipid solubility and molecular size affect the rate of diffusion of solid molecules into red blood cell. So non-polar or lipidic molecules can diffuse to the phospholipid bilayer, as we learned. But polar molecules have to pass through channels. And the rate of diffusion of non-polar molecules depend on how soluble they are, anyways, in lipids, because not all the non-polar molecules, anyways, have the same solubility. And of course, their size is also important in this consideration. Small non-polar molecules, so hydrophobic molecule, will pass through membrane very easily. For instance, if you think about cholesterol, if you think about the small hormones, the ones that we talked about in class, estrogen, they will pass through membrane much faster than larger molecules. This is just a kind of a theoretical thing. Now, what I'm going to do here, because this part 7 is a lab activity, as I told you, the lab activities, of course, in this case, you don't have a video to watch. When that's the case, you just skip on them, okay? Although there are some things that I kind of put there in answer key, I'm telling you to pretty much go ahead and skip on those, okay? Because it's a practical thing where you are giving actually three solutes, and you have to appreciate which one, based on observation, which one is more penetrating or non-penetrating. Okay, so I'm gonna skip on all that, and in this third part we're going to do practice problems, okay, where I would have liked you to show your work. So in the first problem, it asks you what is the percent solution of a solution that contains 25 grams of potassium chloride in 100 ml of solution. This is immediate. You don't even have to do anything here, but it's 25% because you have put 25 grams of something into 100 ml of solution, and that's the definition of percent solution, and so it's 25%, okay? But if you want to really need to do the math, then you'll do 25 gram over 100 ml times 100, which gives you 25%. What's the percent solution of a solution that contains 20 gram of KCl in 200 ml of solution? This is a little bit more tricky, because in this case you have 200 ml and not 100 ml of solution, okay? So there is a little extra step that you have to do. What you can do is calculate first the ratios there, where you know that 20 gram in 200 ml corresponds pretty much. You would, like as you learn in school, when you have a fraction, when you can simplify here, this would become 10 over 100, right? It's the same thing, it's the same ratio. And so once you have done that, now you know here from this second representation, you have the direct representation of gram per 100 ml. And so percent solution will be 10 over 100 ml times 100, which is 10%. Some of you may be able to do this kind of calculation right away, okay, without necessarily doing all of this. HCl is a very strong acid. It completely dissociates into two ions in aqueous solution. What is the osmolarity of 1 millimolar solution of HCl? as we learn, we have to here understand how many particles our compound dissociates into, which in this case is 2 particles. So basically, if you can do this directly, very quickly, that's good. So you will just multiply 1 millimolar times 2, and you'll have 2 milliosmolar. Remember that if you have milli, if your unit of measure is expressed in milli, then that's how you have to you have to keep the consistency. Millimolar cannot become osmolarity, or at least it can become that without doing the proper mathematical conversion. But typically we keep the units of measure. So millimolar becomes milliosmolar. So this is just a times 2, right? And again, here is explain how 1 millimolar corresponds to 0.001 molar, and then you can do your calculations by reasoning on molarity, and then you do your conversion between osmolarity and milliosmolarity at the end. Or you could have, in this case, just kept the millimolarity and come up with a milliosmolarity right away. This is a little bit more complicated way to do it. And in the third one, NaCl has an atomic mass of 58.5. This is the molecular weight. What is the molarity of a solution made by mixing 117 grams of NaCl and filling the container to 1 liter mark? Okay, so this is pretty easy because it's in 1 liter, so there is no fraction of the liter here. So here it asks you what is the molarity. Okay, probably this is the most difficult exercise for you, but when you think about molarity, you have to keep in mind how to calculate the number of moles given the total weight of that substance, which you're given it here, and the molecular weight of 1 mole of substance, which is the atomic mass. And so what you have to consider here is that the number of moles is given by dividing the total weight that you have by the atomic mass. And by knowing that, you can apply this equation where basically you can then calculate the number of moles, okay? The number of moles, and then therefore the molarity, because molarity is number of moles over 1 liter of solution. And so you first calculate the number of moles, and then because you have only 1 liter of solution here, the molarity corresponds to the number of moles. So you have 2 moles of NaCl, and molarity is going to be 2 molar. I know this is a little bit difficult. Probably some of you are having difficulties with molarity, but this is not the time and the place to, I think, to resolve this problem, because really molarity, you understand it more in a chemistry class. And so there are 2 solutions here. If you really want to do deep into the understanding of molarity and you're having difficulties, you can go to tutoring lab, or we can meet together in office hours. If you understand it, that's a good thing. I'm telling you that I'm not going to ask you to calculate molarities in the test, because it's a little bit out of the scope. Okay, you just have to know the definition though. What is molarity? Number of moles per liter of solution. If you can just remember this for me, that's good enough. Okay, and your guided exercise is here. What is the now it asks you what is the osmolarity of 1 molar of calcium chloride? Very easy, okay? I just have to multiply the molarity times the number of particles that calcium chloride release in solution when it's put in solution, which is 3. So pretty simple, okay? So 3 osmolar. And you can do this immediately, okay? So I may give some exercise like this in the test, okay? I'm not going to ask you to infer the molarity or calculate the molarity, but I'm going to give you exercises to convert molarity into osmolarity, which is a very immediate type of calculation you can do for me. I may ask you the percentage, okay, the percent solution. So something like this. What is the percent solution of a solution that contains 20 grams of KCl, in this case in 100 ml of solution? You really don't even have to do any calculation here. It gives you the grams per 100 ml. So you just say 25%, period, okay? All right, so if a solution A has more particles per liter than solution B, then solution A is said to be hyperosmotic, so solution B, while solution B is hyposmotic, solution A makes sense. Now, the number 7 is also a little tricky, okay? And I have given you this picture here to help you visualize this situation. So how can a solution be isoosmotic to a cell? So this is the inside of the cell, and this is the outside of the cell, but also hypotonic. Remember that I told you that osmolarity and tonicity are different things because the osmolarity takes in consideration the number of particles, while the tonicity refers most often to the molarity. And osmolarity and molarity is not always coincide. In this case, we're dealing with ionic compounds. And NaCl is different than calcium chloride because NaCl releases only 2 particles and CaCl2 releases 3 particles. Now, these two, the solution inside the cell, the intracellular fluid and extracellular fluid here, have the same isoosmolarity. Why? Count the number of particles inside the cell and outside the cell, okay? Here I have 1, 2, 3, 4, 5, 6 NaCl molecules, which will produce 12 ions. And here I have 4 CaCl2 molecules, which will produce 12 ions as well, because each of these produces 3. So 12 and 12. These two solutions inside and outside cell have the same osmolarity. But they have, we're talking about different concentrations of the molecules themselves, because you have more molecules of NaCl inside the cell and less molecules overall of calcium chloride outside the cell. And so this solution outside the cell is hypotonic, right? It's hypotonic because the molarity of this is less. Okay, so that's it. I hope that you guys understand this. It's not that difficult, I guess, after hearing the explanation. All right, I'm done with this lab. If you have more questions for me, feel free to email me. Or if you want to meet again, okay, and go over some other things, just let me know.